All right, here comes logarithm graphs. This is an example of transforming logarithms that you'll need to graph usually by hand. You should be able to graph this by hand, or at least if you're graphing with a calculator, know the basics of it. And here we go. Basically what you want to do is you want to focus on the actual log part of it and ignore all the transformations. We're going to focus on graphing y equals log base 3 of x. And the easiest way I know how to do that is to take the problem and rewrite it as an exponential. So it's going to be 3 to the y equals x. So just like that. And you can make a table. The easiest way to make this table, though, is like so. Okay, instead of filling in the x values like we usually do, it's much easier if you fill in the y values. So maybe you do a -2, -1, 0, 1, 2, very standard things that you plug in. And you plug those into the y, so you'll get 3 squared is 9. So the x value will be 9. 3 to the first is 3. 3 to the 0 power is 1. 3 to the negative first is 1 over 3. And 3 to the negative second is 1 over 9. If you kept continuing on in this fashion, -2, -3, -4, -5 for y's, this number gets really small, and it approaches 0, but it never gets to 0. So what that means is you have an asymptote. So graphing this, quick sketch here, very quick sketch. By the way, this is the parent function we're graphing. We're not graphing all the transformations yet. We're going to graph 1, 0. That's always a given. 3, 1. And 9, 2. I am going to run out of room for 9, 2, but let's try to make it happen anyway. 4, 5, 6, 7, 8, 9. Great. 9, 2. So it really starts to flatten out there. And now these are the very important points. 1/3 is -1. So I don't know, maybe there-ish. And putting in a -2 for y gets us 1/9, so we're getting really close. And you're not going to just stop there, but if you look at your calculator stops there. You have to realize that you can get really close to the x-axis, but you're never going to get there. That has to be an asymptote. You have to show me that. And that's your parent function. From there, it's actually pretty simple. We're just going to shift this thing right 1. The most important aspect is that you change the asymptote. The asymptote has to change right 1. So I'm going to draw it right underneath here. I'm going to try to keep everything lined up as best as possible. This is really official. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's lovely, isn't it? And then we're going to go 1, 2, 3, 4, 1, 2, 3. Perfect. So we're going to shift these. The asymptote would go right 1. So I'm going to draw a little dotted line to signify that. That's beautiful. Perfect straight line. And then we're going to move it. All these points are going to go right 1. And then this is going to move them up 1 by your transformation. So the point that was at 1, 0 is now going to go to 2, 0. And it's going to go up to 2, 1. Very simple. This point that was 3, 2 is now going to go right 1. And it's going to go up 1. So now it is at 4, 3. And it's a basic sketch, so you're going to get the same kind of pattern going here. It's just going to asymptote is going to change to the x equals 1 line. And that's pretty much it. That's what you really need to be able to do. But the most important thing is that you understand that it is an asymptote on the y-axis because it's an inverse of the exponential function, which has an asymptote on the x-axis. Alrighty, see you next time.